Hello, my name is Paul. Welcome to this tutorial. Today I'm going to show you how to build your own LED module of 100 watts and 12,000 lumens. It will be powered by a 12 volt power supply, and we are going to use a lot of parts and tools to build this module. So let's do a quick inventory of what you're going to need. You're going to need some burning alcohol to clean the LED and the heatsink, some paper or some fabric to use the alcohol. You will need a heatsink. You can buy it new on Amazon or AliExpress, but I prefer to use garbage one I found in a computer recycling store. So this one was free. You will need a DC to DC booster to transform the 12 volt signal in 24 or 30 volts for the LED. You will need a power supply which could be 12 volt or 24 or 30, but we will use a 12 one of 240 watts. You also need some tools. I have one to cut, I have one to hold, and one to separate the wire protection of the wires. You will need two screwdrivers, one which is flat, another one which is with a cross. You will need some thermal paste, some vagos to do the connections, some wires, jumper wires. Be careful to take some which are at least 0.75 millimeters, or it won't be strong enough to hold all the power of the electricity going through it. There will be a lot of amps going to the LED. It's going to be 3 amps. Speaking of that, you will also need LED COB. I will put the link in the description. It's 30 volt, 3 amps, 100 watts LED. I found on AliExpress for like €5. And it can go up to 12,000 lumens. You will also need some screws and nuts and bolts in M4. I use M4 for this project. I take like 4 M4 screws like that, 2 M4 screws which are shorter, just to attach some things to the others. You will also need a iron solder, soldering wire, a voltmeter, and a amp meter. If you have this kind of stuff, which cost around €10, you can measure at the same time volts and amps. So it's very useful for a project like that. If you're just going to build one module, you don't really need to buy this. You can do everything with a multimeter. But you will need to measure amps and volts in these projects. So let's get into it. So the first thing you're going to need to do is to paste the LED onto the heatsink, and it takes some time to dry, so I will do that as a first step. So I have to remove the plastic protection on the heatsink. Up. I take the LED, I take my alcohol. It can be other products like white spirit. Any dissolvent will do the job. And I'm just gonna put some on the paper, clean a little bit here so it's really without any traces of dirty material. So it's very clean, so it's gonna hold well. That's okay. Now I take my thermal paste, which is commonly used to paste CPU or GPU on heatsink usually. This is basically a CPU heatsink I get. And I put my thermal paste like a little nut is enough, and I try to avoid bubbles. So I just go very close of it, and I put a nut of thermal paste and I take my LED. I try to stay very in the same angles of the heatsink, so later when we put it in a projector, we won't have the problem of geometry issues. So be careful to keep it parallel and to keep it centered with the heatsink. So I will just strongly push on it so the thermal paste can go everywhere under it. Don't break the LED, I just push strongly but not that much. Okay, is it going everywhere? Yeah, a little bit. It's not going everywhere, but you have like 2 per 2 centimeters of thermal paste going under it, so that's fine. And now you can store it. It takes like 1 or 2 hours to dry, and then it's ready. Okay, so I take another LED module which has already dry, so we just can continue the tutorial. And I'm gonna go further. So I have next to prepare the wires of the fan, because we are gonna use a fan with the heatsink, or it won't be cooling down enough. So the LED is gonna be very warm. I forgot to close that thing. So we really need to get this powered by the power supply to keep the heatsink cool. And here I see that I have this metal thing which is sometime coming with the power heatsink. It's not gonna help us, so I will remove it. And I have to just unlock the few things that hold the fan to the heatsink. Everyone is different, so you maybe won't have to do that, but you just have to. Okay, it went down, so now this can go away. I put back my fan, and if you forgot in which way your fan was, there or there, each fan has on the side 2 little arrows. I think you can see them on the camera, but you have arrows which are graved into the plastic, and it's telling you in which sense is going the wind with the fan. So we will need the fan to blow air inside the heatsink. So in my case, the arrow is just telling the wind is going from my right to my left, so I will put back the fan in that way, so it's blowing air on the heatsink. So I just clip it back. Everyone is ready. And I have to prepare my 2 wires on the fan to power them with my power supply, because we won't use connectors like that because we don't have them. So we're gonna directly put the wire onto the power supply with thanks to the Vagos. You have to take the black and red wire. Depending on the fan you have, it could be 2, 3 or 4 wires. In our case, we just put the black and red, which are the ground and the plus, and it'll be fine. You put it 12 volt in it. Usually these fans are 12 volts, but to be really sure, you can check onto the fan, and sometimes it is written. On this one it isn't, but I know it's 12 volt because it was on the box in which I get it. So you just have to cut that and to prepare the wire. This can go away. You don't need it anymore. It's basically, when it's the yellow wire, it's a tachometer which is counting the rotations of the fan, but we don't really need that. So now I'm gonna solder 2 wires going out from the LED. So I take my 2 jumper wires. I prepared myself some wires with soldering wire melt on it, so it's easier to put it. I already did that, but I can do it again. So you see, I have to prepare the LED here with some soldering wire. So I put a little bit on plus and minus. And this is something I have to check now. Before I put the red wire on the side, you have to look which side is what. If you look on the LED, you have the plus here, because you can solder the wires at the same time. You can solder them here and here for plus and minus, but it's also possible here and here. But on the sides, you don't have the plus and the minus to know which who is who. So I will just take my multimeter, I put it to DC, and I do a quick check. And it's not telling me which side is what. So, okay, on this one I am not able to know who is ground and who is plus, so I'm just basically gonna solder it on the LED directly. So let's go. I have to put some soldering wire here. Okay. Some more here. Try to avoid melting the plastic of the LED. Just by touching with the iron only the metal parts of the LED. And also try to avoid touching the yellow part of the LED, because any body material you let on it, it's gonna heat later, it can burn, do smoke, and it's not really helping the LED to last in her life. So now this is done, I'm gonna solder the red one here on plus. Here you go. And the ground on the white one. We have to put 12 volts into the fan and 30 volts into the LED. To put 30 volts into the LED, I use a DC to DC booster. There is a lot existing on internet. You can power like 50 watts, 100 watts, 200 watts. Me, I prefer to use very strong ones, 300 watts, I think. And I prefer that because when it's really, really powerful, it can handle 3 times more than you need. It's gonna cool down very quicker and easier rather than you use a smaller one. For example, this LED is 100 watts. We will power it with a power supply which could be 120 watts, but I prefer to use stronger power supplies and stronger DC to DC boosters, so it's gonna be very powerful and it's not gonna heat at all. I prefer to use it that way. So I will prepare my DC to DC booster. This one has 2 inputs on the side. You can see it's written in minus and in plus. So you have to put your red wires in the in plus. And the out is on the other side. You can see out written. And basically it's gonna take in some voltage. In my case, it's gonna be 12 volts. And it's gonna output a voltage we are gonna set up. So in our case, it's gonna be at around 30 volts because this is what the LED requires on the technical specs. So I'm gonna put the 2 wires of the power supply going in here. I don't need that anymore. And because we are gonna share the voltage of the power supply between the LED and the fan, we are gonna take 2 Vagos, which are gonna take the electricity for the power supply and distribute it to everyone. So the power supply is here. I take the fan. I take the red wire of the fan and obviously I put it with the red wire of the power supply. And I take 2 other jumper wires. In this project I use a lot more wires that I really need, but it's kind of still prototyping, so it's easier to do it that way. But later, when your LED module is really finished, you can shorter many wires. You can even take out some because it would be cleaner. But in my case, this project is evolving a lot, so I prefer to use a lot of them with Vagos. And Vagos are not mandatory. You can solder everything if you want, but it will be harder to repair if you have a problem, and it will be harder to make the project evolve if you want to, for example, change the LED, change that to a bigger one or a smaller one, etc. So I take jumper wires. We are still going out from the 12 volt power supply, which is not plugged. When you work, be sure you don't plug anything before everyone is ready and connected. And these two jumper wires coming out from the power supply, I will put them into the DC to DC booster. So where is my input again? Okay, this side. And when you do that, be careful to have really not any wire touching a side or another, because here it's ground and plus, so you really don't want to have a shortcut around here. So take a look after you did it and be careful with that. We have power going inside my DC to DC booster, power going to the fan, and now I need to send power inside the LED, but at this special step I need to set up the current going out, the current and the voltage going out of the DC to DC booster. So I will have to, at the output of the DC to DC booster, I will have to put my multimeter. And in my case, I will use that because it's easier. But if you want, you can do it with that, but you will have to do it 2 times. For example, if you want to measure, at first you start to measure the voltage you want to send to it, so 30 volt. You can go to the output and take your screwdriver, and this one is helping you to set up the voltage, and you set it up to 30 volts. But after, you will have to set up the amps, the maximum current which is able to go out of the DC to DC booster. And to measure the current, you have to change the wiring of your multimeter from parallel to series, so it's not the same setup. There is a lot of tutorials on the internet to do that, and in my case I have a very easy tool, so I will use it. And I just have to put this tool between my my LED and my DC to DC booster. So now everything is wired. I will need to plug the power supply, so I send electricity to everyone. But the DC to DC booster, when you receive it, it's set up to send like almost no voltage and current at all. So you have to increase it with a screwdriver onto the 2 little how it is called, the 2 little it's potentiometers, but which can be adjusted with a screwdriver turning. So it's basically almost 25 rotation each to go to the maximum. So we will have to slowly look for the right current and right voltage to send to the LED. In my case, it's going to be written on the screen of my multimeter, and I'm going to look for 3 amps and 30 volts. This one, let me see, CV, when it's written CV adjust, it's for the voltage. So this one is voltage, and this one, it's written CC adjust, so it's current control and voltage control. So I'm going to plug everything. When I plug everything, my LED, which is going to be dark because it's not going to receive enough current. But just before, I'm going to put it like that, so I'm not going to be blinded with the powerful light, because it's going to be really, really powerful. It can also heat a little bit, so I'm going to just put it a little bit higher like that, so it's not burning the table. Because yes, usually we say LEDs are cool, but that's not really true. LEDs are cooler than halogen lamps, but for a 100 watt LED like that, it can be very, very hot. So once it's powered up and it's sending its full brightness, you really shouldn't touch it or look at it directly, because it's going to be very harmful for the eyes. So usually when I work, I even take sunglasses to do the setup, but I forget them, so I just send it that way. Maybe one camera is going to be blinded, so I'm going to choose another way. And also, when you power everything up, be careful your DC to DC booster is not on a metal or conductive surface, or because under it it's everything is wired, so you can do a shortcut. So now it's a non-conductive surface, so it's okay. And let's go. I'm gonna plug everything. Okay, my LED is not sending any light as planned, and I can read on my multimeter the LED is receiving 0 watts. It's not taking any watts, and it's receiving 15 volts. And we need to increase that to almost 30 volts with looking at the amps not going further than 3 amps, or it's gonna burn. Okay, so I go with my screwdriver on the voltage adjustment, and I'm just gonna go counterclockwise to pull it up. And now I'm at 30 volts. The amps are at 1.21, and my goal is to go to 3 amps to have the maximum power of the LED, but not more. This is the exact current amount we want to go inside the LED, so it's at the maximum brightness, but without blowing it out. So I have to increase the voltage until I arrive to the goal of 3 amps, and then we will limit the current so it don't go further. Okay, so now basically I move to the other potentiometer. With my screwdriver, I go counterclockwise as well to help the amp reduce until 3 amps. So I start to turn counterclockwise. You will have to do a lot of turns, a lot of rotations before anything is changing. In my case, I was close to it, so I just do few rotation, and I see 3.1, 3.05, and I will stop at exactly 3. Okay, so basically the LEDs you receive are made to receive from 30 to 35 volts. In my case it was that, but the amps, it can depend. So now this one is set up to 33.28 volts and 3 amps exactly. So everything is set up. I can unplug it. I put it back like that, and now the DC to DC booster is set to the right amount of current and volts. You can unplug the multimeter because this is done. But if you change the LED, for example, you put a 200 watt or more or less, you will have to do the setup again. And I can put directly the wires going out of the DC-DC booster to the LED module. And this is at this time. If you want, you can directly solder everything together, so it's stronger, but in my case I keep them here. Now we need to do something which is stronger and connect that to that. So I will unplug the power supply to have more space to work. When you unplug a power supply, be careful to do not let the ground and the plus touch them, because you can have few current left inside the power supply, and it can do a little spark. But it's not dangerous, but I always prefer to avoid that. And now I use some screws to connect them together. So I will take everyone here. And I will use the existing holes above the fan to connect everyone together. And also I will need, if I want to put this LED module inside the projector, I will need to have 4 screws going out of there, so I can connect it to the bottom of a projector by doing 4 holes inside it. So when I do this kind of preparation, I always let at least 4 screws. And my DC to DC booster, I want it on a side, for example this side, because I already have the all the wires are going out this way, so I'm gonna put it there. When I received it, the holes were in M3, so I did with a screwdriver holes in M4, so it can go inside it. And here we go, we have a fully assembled LED module. All the wires you can take, I don't have them here, but cable ties. So you just tighten everything to have something cleaner. But now I can put this LED module inside a projector thanks to the 4 screws above it. So I have to do a measurement of the distance between the 4 screws, do 4 holes inside a projector, and I can then tighten it with bolts and nuts. And of course you have to put back the power supply when it's inside it. Let's do a quick test again, so we will see if everyone is still working with my LED sending light to somewhere else. And yeah, now it's fully bright.
Thank you for watching this video. As you've seen, there are many things to improve, create or remix, so please feel free to participate to the community.
You can follow us on Instagram, you can go on our website visiophare.org, where we have a lot of documentation and blueprints we share for free to help you build your own overhead projector or convert your original one with LED. Feel free also to go on the forum of Visiophare to share your builds, ask your questions, share your ideas, and together I'm sure we can improve a lot the possibilities of this fascinating machine. Thank you and see you soon.
Thank you.